One is mass transfer and other is process dynamics and control. So I have very few questions of them. The first question is related to the J factor analogy. And we discussed in the class also the Reynolds analogy and the Chilton-Corbin analogy. It's very simple formula, F by 2 is equals to Jm, where Jm is the Sherwood number divided by Reynolds number into Schmidt number to the power 1 by 3 equals to Jh, where Jh is equals to the Sherwood number divided by Reynolds number or the Prandtl number. And in fact in some books it is Sherwood replaced by the Nusselt number. So the given relation is this. So that is our option, because they are saying find out the relationship between the Sherwood, Reynolds and the Schmidt. So this is the relationship according to the J factor analogy. Now the next question is of PDC. In the PDC they have given us the known interacting system. And in the non-interacting system, this is the first tank having the height h1. Then that is the second tank having the height h2. This is Fi, F1, and it's a non-linear resistance given as K under root h1. And this is F2, again in nonlinear resistance given as K under root H2. The value of K is given as 4 here, already given, and Fi steady state value is given as 16. So units are not clear whether it is centimeter or meter, so you can check it. The area data is also given. Area A1 is equals to A2 is equals to 28 centimeter square. So whether it is meter or centimeter, that will be clear when gate question will arrive. So that is a given data to us. Now we all know that in the case of non-linear resistance, the transfer function h bar s divided by Fis will be R2 divided by 1 plus tau P1 into S, where R2 is the nonlinear resistance given by the reciprocal of the outlet flow rate at the steady state height, and that time constant is given as AR2, where A is the area and R2 is the same value. So that is a concept that you need to remember in the case of non-linear resistance. So for calculating the non-linear resistance, H1, H2. Now at the steady state, the inlet flow rate will be same as the outlet flow rate, of the second tank. So 16 is equals to 16 is equals to 16. Okay. Also at steady state, F1 SS will be equals to K times under root of H1 SS. Also F2SS will be equals to K times under root of H2SS. Now what is F1SS? 16. What is the value of K? 4. Again, what is F2SS? 16. What is the value of K? 4. Which means the H1SS and the H2SS are same, and there comes out to be 16. So steady state, at the steady state, both the height of the liquid level in the tanks are same. Now the value of resistance. The value of resistance, if I talk about for the tank number 1. So for the tank number 1 will be 1 upon the derivative. So what is the derivative? It's K divided by under root of H1SS. So H1SS is 16, K is given as 4. So the value can be calculated and the value comes out to be 2. And as the relations are same, the H1 H2 value is same. So this will also be the value for the R2 of the tank 2. So for both the tanks, the value of the nonlinear resistances are also same, and that is equals to 2. Now they are saying calculate the transfer function. So the transfer function of the final height, liquid level height, to the initial inlet flow rate can be calculated as the transfer function of the tank 1 into the transfer function of the tank 2. So the transfer function of the tank 1 is 1 upon 1 plus tau P1 into S, where tau P1 is A1, R2 of tank 1 into S, into second it's R2 for the tank 2, divided by 1 plus A2, R2 for the tank 2 into S. So it's 1 upon 1 plus 28 into 2, it's 56 S into by 1 plus 28 into 2, it's 56 S. So the final answer is 2 divided by 1 plus 56S whole square. So that is your answer. So very simple question, just to need to remember this concept. Now the second question in the mass transfer. So the question is, an absorption column is given to us. Initial value is given, it's 0.02, and obviously it's mole of C to the mole of A. 95% separation is required. So that means here the Y2 will be only the 5% of Y1. because 95% is separated, so the remaining will be the 5%. So 5% of this will be 0.001. The solvent used is pure and the exit solvent composition is required. So we all know in the case of absorption, the equilibrium diagram is, first of all we plot the equilibrium line. Equilibrium line is given as y is equals to 2x. Then the inlet of the gas, which is y1, outlet of the gas it's y2, inlet of the solvent is x2. So y2 and x2 becomes 1 point. And what is the strategy? Strategy is draw a line parallel to the x-axis from y1 so that it hit the point at equilibrium, and we find out the point here, and that point is known as x1 star. So the x1 star will be y by 2. So what is y1? Y1 is 0.02. So x1 star will be 0.02 by 2, that is 0.01. Now what is the second step? The second step is from this point we join this point. Okay, so that is an operating line. Let the slope of this operating line is m. So what is m? M is y2 minus y1 divided by x2 minus x1. So y2 is 0.02 minus y1 is 0.001 divided by x2, that means this. So it's 0.01 minus this one is 0. So that is the slope of the operating line, and the slope of the operating line is also equals to the LS minimum divided by GS. So that is equals to this value, and when we solve this value comes out to be 1.9. Now GS is given to be 50. That means the value of LS minimum comes out to be 95. Now the data is given that the operating flow rate is twice the minimum. So LS operating will be twice the LS minimum. So that comes out to be 190. Now in the same diagram, this is y1, this is y2, y is equals to 2x, this is x2, that is the first point. Now from this point, the slope is known. What is the slope? The m value is 1.9. So with the help of this slope, we draw a line, and the point at which it cuts this becomes the actual x1. Now what is the question? This x1 is required. So again, let's say the slope of this line is m dash. So what is m dash? M dash is 0.02 minus 0.001 divided by x1 minus 0. And the slope is equals to LS operating divided by GS. So LS operating is given as 190, GS is given as 50. The value of x1 can be calculated as 0.005. So this is known as the graphical approach of solving this question. Now, if we go by the analytical approach, then we can apply the material balance. So the material balance is GS Y1 plus ls x2 is equals to gs y2 plus ls x1. Now, in this point, the y1 is known, the y2 is known, the x2 is known. So the equilibrium relationship y is equals to 2x. So if I use this equilibrium relationship here and I use this y as y1, then the value of x becomes x1 star. So with the help of y1, which is given as 0.02, we can calculate x1 star. And if I use it here, then the same relation can be written as gsy1 plus this ls becomes ls minimum. x2 is equals to gsy2 plus ls minimum into x1 star. So gs is 50, y1 is 0.02, x2 is 0, y2 is 0.001, gs is 50, x1 star it's 0.01. So ls minimum can be calculated by this. ls minimum comes out to be 95, then ls operating is twice of this, and that comes out to be 190. Now when this is obtained, so you can again use this. So gs is 50, y1 is 0.02, ls becomes ls operating, that is 190, x2 is 0, gs is 50, y2 is 0.001, ls operating is again 190, and x1 can be calculated, which is 0.005. So that is the analytical approach. So these two approaches are very lengthy. There is a third approach also, which is equilibrium approach, that we discuss in class. So for you guys, if you want to recommend your juniors, you can recommend here in the gate coach, because in the gate coach we also go for the third approach, that is known as the equilibrium approach, in which we get the answer in just one line. Now the next question is of PDC, where they are saying that match the different diagrams, like this is the diagram. So that becomes stable. Clearly that is first order system, which is Kp1 divided by 1 plus tau P1 into S. Again in the next diagram, it is just increasing like the ramp. It's like the ramp. It is increasing. So that belongs to, according to the option, is so because of this S present in the denominator, this is shooting up and will go to the unbounded. Clearly, if I go for the third diagram, again that looks like an inverse response, which is Kp1 divided by 1 plus tau P1S minus Kp2 divided by 1 plus tau P2S. The condition is tau P1 by tau P2 greater than Kp1 by Kp2 greater than 1, and S has a positive 0. So the 0 is positive and that is the condition. So that becomes the inverse response. So these three diagrams can be estimated, and according to the given option we can estimate the final accurate answer. Now the next question is of phase margin, and according to the given diagram, the open loop transfer function is 5 e to the power minus 0.1 s divided by 0.5 s plus 1. So that is a given transfer function, in which this is what is a dead time system, and this is what is the first order system. So in the question in which we need to calculate the phase margin, the first task is to find out the crossover frequency. And in the question of phase margin, the crossover frequency is known as gain crossover. And the gain crossover is the frequency at which the amplitude ratio of the given system becomes 1. So we calculate the amplitude ratio for this, and amplitude ratio is 5 for that time system, the amplitude ratio is 1. For the first order system, it is 1 upon 1 plus tau p is 0.5 omega whole square under root. So when we put AR equals to 1, then omega can be calculated, and this omega comes out to be 9.7979. Again, it's radian per unit time, whatever the time given in the question. And when this crossover is known, then what we do, we go for the phase margin curve. So what is the phase margin here, or you can say the phi curve. So what is the phi here? The phi here is for the dead time, it is minus TD omega into 180 by pi, plus for the first order system, it is tangent inverse minus tau p omega. So what we do, at the gain crossover, we calculate what is the value of the phase angle. So if I put omega as the gain crossover frequency, then the value of phi can be calculated, and the value of phi comes out to be minus of 134.6245 degree. And once this phi is known, we can calculate the algebraic difference between this. So this thing is known as the phase margin, where phase margin is absolute difference between these two. And when you calculate this, it comes out to be 45.3755 degree. So this difference is known as the phase margin. So that can be calculated. Very simple question. Now the next question is of mass transfer, and in that question the value of XD is given to us. The value of XD is given to us as 0.95. The value of feed is given, it's equimolar, so it is 0.5. The value of relative volatility is given, that is given as 2. And they are saying find out the value of R minimum. So if I go for the diagram, that is a diagonal. This is, let's say, equilibrium curve. So the feed is equimolar, and the XD value is given as 0.95. So this one is also 0.95, and the feed is given as saturated saturated liquid. So for that case, it comes here, cut it, and it cuts here. Now that point we need to calculate. So this point is same as this x. So x is given as 0.5. Now I need to calculate y, and this curve can be estimated by using the alpha, which is y is equals to alpha x divided by 1 plus alpha minus 1 into x. So when we put x as xf, the value of y can be determined, and if the value of y is known to me, this point is known to me, then the slope of this line will be r min divided by r min plus 1, which is about 0.95 minus the y that I calculate divided by 0.95 minus the x that I calculate. So the y comes from this side, r minimum can be calculated from this, and r minimum comes out to be 1.7. So that is also one of the question in the mass transfer. And then there is a theoretical question from the PDC on what principle, on what effect the thermocouple senses the temperature. So if you know this, अगर आपने सारे effect पढ़े हैं तो आप इसका आंसर कर सकते हो, नहीं पढ़े तो नहीं कर पाओगे, छोड़ना पड़ेगा. There are 4 types of effect given: the Nernst effect, the Peltier effect, the Maxwell effect and the Seebeck effect. And if you know कि थर्मोकपल कैसे सेंस करता है, सीबक इफेक्ट के थ्रू, कि जब दो एंड्स पे टेम्परेचर डिफरेंस मेंटेन्ड होता है, सो बिकॉज ऑफ दैट टेम्परेचर डिफरेंस द ईएमएफ जनरेट्स. सो दैट इज अ सीबक इफेक्ट, एंड ऑन द बेसिस ऑफ दैट द थर्मोकपल सेंसेस द टेम्परेचर. सो इफ यू नो दिस क्वेश्चन, अगर आपने पढ़ा है तो आप इसे अटेम्प्ट कर पाओगे. थैंक यू.